Let's now explore where and how the virtual machines are stored. Let's begin with shared storage. Shared storage consists of storage systems that your ESXi host uses to store virtual machine files remotely. The host accesses these systems over a high-speed storage network. Shared storage helps in operating virtual machines on different hosts. It allows multiple ESXi hosts to access the storage even if one or more hosts become unavailable. Several of the other vSphere features also require shared storage infrastructure to work properly. Some of these include DRS, DPM, storage DRS, high availability, fault tolerance. vSphere supports the following storage protocols: Fiber Channel over Ethernet, iSCSI, Network File System, Local Storage, Virtual Volumes. These storage protocols give you the choice and flexibility to adapt to changing IT environments. Each storage option has its own strengths and weaknesses. And for this reason, VMware does not regard one storage type as better than another for virtualization. Click each storage protocol to know more. Fiber Channel is a high-speed network technology that is primarily used to connect storage components over a storage area network, or SAN. Fiber Channel solutions require dedicated network storage devices that are not typically accessed through other LAN devices. Fiber Channel is commonly used for vSphere VMFS data stores and boot LUNs for ESXi. vSphere provides native support for Fiber Channel protocols and Fiber Channel over Ethernet, or FCOE. It supports fiber channel speeds from 2 GB per second to 16 GB per second. In FCOE, the fiber channel traffic is encapsulated into Ethernet frames, and the FCOE frames are converged with networking traffic. By enabling the same Ethernet link to carry both fiber channel and Ethernet traffic, FCOE increases the use of the Ethernet infrastructure. FCOE also reduces the total number of network ports used in the network environment. iSCSI uses Ethernet connections between computer systems or host servers and high-performance storage systems. iSCSI is commonly used for VMFS data stores. It does not require special-purpose cables and can also be run over long distances. You can also do thin provisioning on iSCSI LUNs, whereas this is not possible with NFS. ESXi provides native support for iSCSI through the following iSCSI initiators: independent iSCSI hardware initiators, dependent iSCSI hardware initiators, iSCSI software initiators. Network File System, or NFS, is an IP-based file sharing protocol that is used by network-attached storage, or NAS, systems to allow multiple remote systems to connect to a shared file system. It uses file-level data access, and the target NAS device controls the storage device. NFS is the only vSphere-supported NAS protocol which supports NFS version 3 over TCP/IP, along with simultaneous host access NFS volumes. You cannot initialize or format an NAS target from a remote server. The NAS server is responsible for the file system where the data is stored. Local storage can be internal hard disks located inside your ESXi host, or it can be direct attached storage. Local storage does not require a storage network to communicate with your host. You need a cable connected to the storage unit and, when required, a compatible HBA in your host. Virtual Volumes is a new integration and management framework that virtualizes SAN or NAS arrays, enabling a more efficient operational model that is optimized for virtualized environments. Virtual Volumes simplifies storage operations by automating manual tasks. It provides administrators with finer control of storage resources and data services at the VM level, simplifying the delivery of storage service levels to applications. In vSphere, virtual machines are stored in containers called data stores. These are logical volumes that allow you to organize the storage of your ESXi hosts and virtual machines. You can browse the data stores to upload and download files within the vSphere web client. Data stores can also be used for storing ISO images, virtual machine templates, and floppy images. Depending on the type of storage, data stores can be of the following types: VMFS data stores, NFS data stores, virtual SAN data stores. Click each data store type to learn more. The vSphere VMFS format is a special high-performance file system format that is optimized for storing virtual machines. You use the VMFS format to deploy data stores on block storage devices. A VMFS data store can be extended to span several physical storage extents, including SAN LUNs and local storage. This feature allows you to pool storage and gives you flexibility in creating the data store necessary for your virtual machines. You can use NFS volumes to store and boot virtual machines in the same way that you use VMFS data stores. The maximum size of NFS data stores depends on the support that an NFS server provides. ESXi does not impose any limits on the NFS data store size. Virtual Volumes virtualizes SAN and NAS devices by abstracting physical hardware resources into logical pools of capacity. These pools of capacity are known as virtual data stores. The virtual data store defines capacity boundaries, access logic, and exposes a set of data services accessible to the virtual machines provisioned in the pool. Virtual data stores are purely logical constructs that can be configured on the fly when needed, without disruption, and don't require formatting with a file system. Virtual SAN is a distributed layer of software that runs natively as a part of the ESXi hypervisor. You can activate virtual SAN when you create host clusters. Alternatively, you can also enable virtual SAN on existing clusters. The hosts in the virtual SAN cluster need not be identical. Even the hosts within the virtual SAN cluster that have no local disks can participate and run their virtual machines on the virtual SAN data store. When enabled, virtual SAN works with the virtual machine storage policies. It monitors and reports on policy compliance during the lifecycle of the virtual machine. If the policy becomes non-compliant because of a host, disk or network failure, or workload changes, virtual SAN takes remedial actions. Virtual SAN can be configured as hybrid or all-flash storage. In a hybrid storage architecture, virtual SAN pools server-attached hard disk drives, or HDDs, and SSDs to create a distributed shared data store that abstracts the storage hardware to provide a software-defined storage tier for virtual machines. Flash is used as a read cache write buffer to accelerate performance, and magnetic disks provide data persistence. In all flash storage architecture, flash devices are intelligently used as a write cache, while SSDs provide data persistence and consistent fast response times. Note that virtual SAN is a separate paid offering and is not included with vSphere. Virtual Volumes is a new virtual machine disk management and integration framework that enables array-based operations at the virtual disk level. It makes SAN and NAS storage systems capable of being managed at a virtual machine level. With Virtual Volumes, most data operations are offloaded to the storage arrays. Virtual Volumes eliminate the need to provision and manage large numbers of LUNs, or volumes per host. This reduces operational overhead, while enabling scalable data services on a per virtual machine level. Storage Policy-Based Management, or SPBM, is a key technology that works in conjunction with Virtual Volumes. This framework provides dynamic resource allocation and management of storage-related services. Administrators can specify a set of storage requirements and capabilities for any particular virtual machine to match service levels required by hosted applications. The networking features of vSphere provide support for monitoring networks, managing network resources, and networking best practices. Network virtualization abstracts the network into a generalized pool of network capacity. The unified pool of network capacity can then be optimally segmented into logical networks directly attached to specific applications. The virtual machines communicate with each other and with the physical components through the virtual networks. vSphere uses virtual NICs and virtual switches for virtual networking. Uplink adapters are the physical NICs in each host that connect the physical network to the virtual networks, and the virtual switches regulate the traffic between the virtual machines. vSphere uses NSX as the network virtualization platform for the software-defined data center, or SDDC. NSX allows you to treat your physical network as a pool of transport capacity, with network and security services attached to virtual machines with a policy-driven approach. Virtual machines use the virtual networking to communicate with each other and with the physical world. Virtual networking is similar to physical networking. Each virtual machine on the ESXi host has a network address with 0 or more virtual network cards. The virtual network cards are connected to virtual switches, which allow virtual machines on the same host to communicate with each other using the same protocols that would be used over physical switches. Virtual switches also allow virtual machines to communicate with VMs on other hosts. The ESXi hosts are managed by vCenter Server and leverage the network for features such as vMotion, high availability, and DRS. A virtual machine can be configured with 0 or more virtual Ethernet adapters, each of which has its own IP address and MAC address. As a result, virtual machines have the same properties as physical machines from a networking standpoint. vSphere supports a number of networking features, including the following: virtual LANs, traffic shaping, port mirroring, quality of service or QoS, and differentiated services code point or DSCP, NetFlow, Cisco Discovery Protocol or CDP, and Link Layer Discovery Protocol or LLDP. Click each feature to learn more. Virtual LANs or VLANs provide logical separation of the network traffic and are used to isolate different subnetworks, such as a test or restore network. Traffic shaping is a feature that allows you to regulate and/or restrict the inbound and outbound network bandwidth of a group of virtual machines. This feature helps to reduce the congestion in a virtual network. Port mirroring allows you to monitor a virtual machine's traffic for troubleshooting or intrusion prevention. This feature allows you to capture the total traffic sent to or from a virtual machine for analysis. Quality of service or QoS and differentiated services code point or DSCP are networking standards that allow network switches to prioritize certain network traffic over others. An example of this is prioritizing the voice traffic from a call manager server so that its performance is improved. NetFlow is a network monitoring tool that determines the top talkers on a network. It also monitors other metadata about the communications that occur on the network. Cisco Discovery Protocol, or CDP, and Link Layer Discovery Protocol, or LLDP, are the discovery protocols that are used to identify the neighboring physical network switches. CDP and LLDP can also be used to discover and troubleshoot misconfigurations in a network. Virtual switches are the key networking components in vSphere virtual networking. You can use virtual switches to attach virtual machines to the physical network. You can also use them to create isolated networks to be used during testing and development. Virtual switches help you to reduce network clutter by reducing the number of physical network cables plugged into your ESXi hosts. Virtual switches maintain a MAC port forwarding table and perform the following functions. Look up each frame's destination MAC when it arrives. Forward a frame to one or more ports for transmission. Avoid unnecessary deliveries. vSphere supports two main types of virtual switches: standard switch, distributed switch. Click each type to learn more. A standard switch can bridge traffic internally between virtual machines in the same port group and link to external networks. You can use standard switches to combine the bandwidth of multiple network adapters and balance communications traffic among them. You can also configure a standard switch to handle physical NIC failover. A standard switch models a physical Ethernet switch. The default number of logical ports for a standard switch is 120. You can connect one network adapter of a virtual machine to each port. Each uplink adapter associated with the standard switch uses one port. VMware vSphere Distributed Switch provides a centralized interface from which you can configure, monitor, and administer virtual machine access switching for the entire data center. Distributed switch provides simplified virtual machine network configuration and enhanced network monitoring and troubleshooting capabilities. The networking configuration and management for all hosts that are associated with the distributed switch is centralized on the vCenter server system. NSX handles data across virtual switches without interacting with the physical switching environment. NSX exists in the ESXi environment and is independent of the underlying network hardware. NSX is an approach to networking that enables data center managers to create an operational model for the underlying physical network. It has the ability to be deployed on any IP network, including existing traditional networking models and next-generation fabric architectures from any vendor. NSX capabilities extend to the following functional services: logical switching, logical routing, logical firewall, logical load balancer, logical virtual private network. Click each service to know more. The logical switching capability of the NSX platform provides customers the ability to spin up isolated logical level 2 or L2 networks with the same flexibility and agility as that of virtual machines. The distributed routing capability of the NSX platform provides an optimized and scalable way of handling east-west traffic within a data center. The amount of east-west traffic in the data center keeps growing, and the new collaborative, distributed, and service-oriented application architecture of the SDDC demands higher bandwidth for server-to-server communication. The NSX platform includes distributed kernel-enabled firewalling with line rate performance and virtualization. It also includes identity-aware with activity monitoring, among other network security features native to network virtualization. This service offers distribution of workload across multiple servers, as well as high availability of applications. SSL VPN Plus allows remote users to access private corporate applications. IPsec VPN offers site-to-site connectivity between an NSX Edge instance and remote sites. L2 VPN allows you to extend your data center by allowing virtual machines to retain network connectivity across geographical boundaries. Resource management is the allocation of resources from resource providers to resource consumers. Resource management allows you to dynamically reallocate resources so that you can more efficiently use available capacity. The various features that allow you to perform resource management include vMotion, Distributed Resource Scheduler, or DRS, Distributed Power Management, or DPM, Storage vMotion, Storage DRS, Storage I/O Control, Network I/O Control. Let's discuss each feature in detail. vMotion allows you to migrate a running virtual machine from one ESXi host to another without any downtime. You can also change both the host and the data store of the virtual machine during vMotion. When you migrate virtual machines with vMotion and choose to change only the host, the active memory and precise execution state of the virtual machine is rapidly transferred to the new host. vMotion suspends the source virtual machine, copies the bitmap to the new ESX host, and resumes the virtual machine on this new host. The associated virtual disk remains in the same location on storage that is shared between the two hosts. Only the RAM and the system state are copied to the new host. When you change both the host and the data store, the active memory and precise execution state of the virtual machine is moved to a new host, and the virtual disk is moved to another data store. vMotion migration to another host and data store is possible in vSphere environments without shared storage. The different types of vMotion include Cross vSwitch vMotion. Cross vSwitch vMotion allows you to seamlessly migrate a virtual machine across different virtual switches while performing a vMotion. Cross vCenter vMotion. Cross vCenter vMotion is the ability to migrate a virtual machine from a host server that is managed by one vCenter server to a host managed by another vCenter server. Long-distance vMotion. Long-distance vMotion allows you to migrate virtual machines across a WAN to another site. The latency across sites is 150 milliseconds, RTT. Distributed Resource Scheduler, or DRS, aggregates computing capacity across a collection of servers into logical resource pools. It intelligently allocates available resources among the virtual machines based on predefined rules that reflect business needs and changing priorities. Each DRS cluster has a root resource pool that groups the resources of that cluster. The resource pools decide how virtual machines share memory resources. A resource pool allows you, as the administrator, to divide and allocate resources to virtual machines and other resource pools. A resource pool allows you to control the aggregate CPU and memory resources of the DRS cluster. Resource pools also allow you to prioritize resources to the highest value applications in order to align resources with business goals automatically. When a virtual machine experiences an increased load and there is pressure or scarcity of available resources on its current host server, DRS may redistribute some virtual machines across some of the host servers to satisfy the resource need of the consuming virtual machine. DRS offers several benefits. It helps increase operational efficiency of your data center by automatically optimizing hardware utilization and responds to changing conditions. It also allows you to dedicate resources to business units while still profiting from higher hardware utilization through resource pooling. With DRS, you can conduct zero downtime server maintenance and lower power consumption costs by up to 20%. Distributed Power Management, or DPM, is a feature of VMware DRS that continuously monitors resource requirements in a DRS cluster. When resource requirements of the cluster decrease during periods of low usage, VMware DPM consolidates workloads to reduce the power consumed by the cluster. When resource requirements of workloads increase during periods of higher usage, VMware DPM brings powered-down hosts back online to ensure that service levels are met. DPM compares the available capacity in a DRS cluster against resource requirements of virtual machines, plus some administrator-defined buffer capacity requirements. If DPM detects there are too many hosts powered on, it will consolidate virtual machines onto fewer hosts and power off the remaining machines. VMware DPM brings powered-off hosts online once again to meet virtual machine requirements either at a predefined time or when it senses increasing virtual machine requirements. Storage vMotion enables you to migrate a virtual machine and its disk files from one data store to another while the virtual machine is running. It performs a virtual machine migration with zero downtime, continuous service availability, and complete transaction integrity. With Storage vMotion, you can either choose to place the virtual machine and all of its disks in a single location, or select separate locations for the virtual machine configuration file and each virtual disk. Storage vMotion enables you to perform proactive storage migrations, simplify array migrations, and improve virtual machine storage performance. Storage vMotion is fully integrated with VMware vCenter Server to provide easy migration and monitoring. Storage DRS provides smart virtual machine placement and load balancing mechanisms based on I/O and space capacity. It helps decrease operational effort associated with the provisioning of virtual machines and monitoring of the storage environment. Storage DRS allows you to monitor the storage habits of the virtual machines and to keep the storage devices more evenly loaded. It is a load balancer just like DRS but focuses on storage devices. It monitors disk I/O latency on the shared storage devices to determine if a particular disk device is overburdened. Storage DRS distributes the load in the storage clusters as required, which ensures a smooth performance. It can be set up to work in either manual or fully automated mode. Click each mode to learn more. In the manual mode, Storage DRS makes balancing recommendations that an administrator may approve. In the automatic mode, Storage DRS makes Storage vMotion decisions to lower I/O latency to keep all virtual machines performing optimally. Storage I/O Control, or SIOC, provides storage I/O performance isolation for virtual machines and enables administrators to comfortably run important workloads in a highly consolidated virtualized storage environment. It protects all virtual machines from undue negative performance impact due to misbehaving I/O-heavy virtual machines. Note that SIOC can have negative performance if it is not set properly. SIOC protects the service level of critical virtual machines by giving them preferential I/O resource allocation during periods of congestion. It achieves these benefits by extending the constructs of shares and limits, used extensively for CPU and memory, to manage the allocation of storage I/O resources. SIOC can trigger device latency monitoring that hosts observe when communicating with that data store. When latency exceeds a set threshold, the feature engages to relieve congestion. Each virtual machine that accesses that data store is then allocated I/O resources in proportion to their shares. SIOC enables administrators to mitigate the performance loss of critical workloads due to high congestion and storage latency during peak load periods. The use of SIOC will produce better and more predictable performance behavior for workloads during periods of congestion. Administrators and architects need a simple and reliable way to enable prioritization of critical traffic over the physical network if and when contention for those resources occurs. Network I/O Control, or NIOC, addresses this challenge by introducing a software approach to partitioning physical network bandwidth among the different types of network traffic flows. It does so by providing appropriate QoS policies enforcing traffic isolation, predictability, and prioritization, thereby helping IT organizations overcome the contention resulting from consolidation. NIOC allows you to ensure that a given flow will never be allowed to dominate over others, which prevents drops and undesired jitters. It also allows flexible networking capacity partitioning to help users deal with overcommitment when flows compete aggressively for the same resources. NIOC enforces traffic bandwidth limit on the overall VDS set of DV uplinks and uses them efficiently for network capacity by load-based teaming. VMware vSphere delivers maximum availability of your virtualized environment, making unplanned downtime a thing of the past. The enhanced availability also minimizes unplanned downtime through automated virtual machine restart, automating virtual machine placement and load balancing, backup and recovery, and site-wide disaster recovery further enhances availability. The vSphere availability features include vSphere data protection, high availability, fault tolerance, vSphere replication. Let's discuss each feature in detail. VMware vSphere Data Protection is a robust, easy-to-deploy, disk-based backup and recovery solution for VMware virtualized environments. The feature enables both local data protection and off-site disaster recovery. Backups are performed locally and then replicated off-site for disaster recovery. Data protection is managed using the vSphere web client, an interface that is familiar to the vSphere administrator. With data protection, tasks such as creating backup jobs, restoring virtual machines, and setting up backup data replication are intuitive. Let's take a closer look at some of the features of data protection. Data protection includes agents that enable application-consistent backup and recovery from a wide variety of servers, including the Microsoft SQL Server, Microsoft Exchange Server, and Microsoft SharePoint Server. It allows you to restore the replicated backup data to a target location or back to the source location. This functionality provides several retention and recovery options to satisfy a wide variety of business requirements. Data protection also includes automated backup verification scheduled jobs that routinely restore virtual machines, boot the guest operating systems, check for VMware Tools heartbeats to verify the virtual machines have been recovered successfully, and then delete the restored virtual machines. The data protection support for backup data storage provides increased reliability and backup data capacity with minimum impact on network bandwidth or performance. High availability provides easy-to-use, cost-effective high availability for applications running in virtual machines. In the event of physical server failure, affected virtual machines are automatically restarted on other servers with spare capacity. In the case of operating system failure, high availability restarts the affected virtual machine on the same physical server. The combination of high availability and the other availability features of the vSphere platform provides organizations with the ability to select and easily deliver the level of availability required for all of their important applications. High availability enables you to minimize unplanned downtime and IT service disruptions, while eliminating the need for dedicated standby hardware or the installation of additional software. It provides affordable, uniform, high availability across the entire virtualized IT environment, without the cost and complexity of failover solutions tied to either operating systems or specific applications. To monitor operating system failures, high availability monitors heartbeat information provided by the VMware Tools package installed in each virtual machine in the cluster. Failures are detected when no heartbeat is received from a given virtual machine within a user-specified time interval.